Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome to the class of CS103 Computer Programming lectures held at FCSE GIK Institute. Um in today's lecture, I will be talking about control structures, especially the selection structures in C++. In the earlier lectures, I've already discussed something about the background of computer programming, along with the background of computers at the start, and then some basic things about how data is stored in said computers, etc. The language of the computers, and then I talked about how the programming languages evolved over time in chapter 1. Then I talked about something about the basics of a computer program, of a C++ program. So in that, we basically talked a bit about what the header files and the preprocessor directives and other things. And then in chapter 3, I discussed something about the input output. And here there was a more detailed discussion about manipulators and other input stream and output stream and other things, extraction operators, etc., and how they work. So in today's lecture, it will be more about different selection structures that exist in C++ and how they work. Notice that almost similar kind of structures, selection structures exist across many other languages as well. So it's not necessarily just limited to C++, but since our language for this course is C++, so we'll be talking more about control structures and especially the selection structures. So the objectives of this chapter are that we'll learn more about control structures. We'll examine relational operators. We'll discover how to use the selection control structures, that is if and if else. We'll examine integer and Boolean type data types and logical or Boolean expressions, what they are and how they're evaluated and how they work. We'll examine some logical operators. We'll be exploring how to form and evaluate logical or Boolean expressions. We'll be learning how relational operators work with the string data type. So again, string data type is something that I have already told you is a little bit different from the other data types. So there's special focus on string data type in this particular lecture. We'll become aware of short circuit evaluation, how to evaluate a short circuit. We learn how the conditional operator, that is question mark and colon, works. We learn how to use pseudocode to develop, test, and debug a program. We'll discover how to use a switch statement in a program. We learn how to avoid bugs by avoiding partially understood concepts. We learn how to use the assert function to terminate a program. So these are all some of the statements and stuff that we'll be doing in this particular lecture. So let's begin by starting with the control structures. What is a control structure? Well, how does a computer program work? How if you write a program, what are the different options in C++? That a set of instructions, a program is a set of instructions, right? So those set of instructions will be executed. Well, the first thing, of course, is that it can be done in sequence. So by sequence, it means that the first command is run, then the second command is run, then the third command is run. So it runs on in a particular sequence. The second option is, of course, that we can make a choice. And we can say that, okay, skip a particular piece of code and move on to the next piece of code directly. So this piece of code should not be run. So this is like you have got a root, a path, and you've got a fork. And from that fork, you basically want to, take one particular path on the way. And this is what we call branching out. So this is like selectively branching out or making a choice and not going on a particular path by choice. So this is a selective operation, and in this you actually choose that you are going to skip one piece of code while executing the other piece of code, depending on the condition being met. What is a condition? What is that? I will come to it in this lecture actually, and this is the topic of the current lecture. Then another way that we can actually control how or code can run is that you run a piece of code, you again go back to the start of that particular piece, and then you again run it, and you keep on doing it. You keep on repeating it, looping over it until a certain condition is violated, or you basically want to move out of that particular repetition code. In that case, you're actually going to iteratively repeat or loop over a piece of code. So this is like going over one thing again and again and again multiple times until a certain goal has been achieved. This is called repetition and or looping, and this is something that we'll study in the next lecture. Another way that a particular code can be executed is by calling a function. So I've already discussed about functions in my zero lecture actually, and also I think I've discussed the predefined functions. I've just given a hint of what a function is, but formally functions will be taught in I think 2 lectures from now. So in when I talk in about I think chapter when I talk a few chapters later, I'll be talking about functions. So if you think about control structures, there are 2 main control structures. Function is also, of course, one of the common things. Similarly, the sequence command is one of also the running in sequence is something that is also necessary for all programs, more or less. But there are 2 things that are interesting and very commonly used, as well as very useful in a computer program. One of them is basically branching out or selection. So you make a choice. I don't want to run this code for now because it does not meet a particular criteria. And I want to, the other thing is that you want to repeat a piece of code multiple times. And both of them combined play a very important role in controlling how a particular piece of code is running. So selection and repetition are 2 of the most common control structures. And to explain what they are and how they flow, the first one is when you run commands in a sequence. So we already know about the flow chart diagrams. And here I show that when a process starts, you execute statement 1, then you execute statement 2, then you move on until you reach statement n, and after that you end the program. So this is all running in sequence. You're going to execute this statement, then this statement, then this statement, and so on until you reach this statement, and then you end the program. This is how a selection structure looks. So in here, you start, you reach the point of an expression, you evaluate the expression. If it is true, you execute statement 1 and reach this point. If the expression is false, you actually execute statement 2 and reach this point. Notice that in the selection structure, we actually execute one of these statements, and both will never be executed. It's either this or this, but not both, as you have already studied in discrete structures course. So this is like that. This is either statement 1 or statement 2, but not both. So if the expression is false, statement 2 will be executed, but not statement 1. And if the expression is true, then statement 1 will be executed, but not statement 2. Why that is happening is because the expression can either be true or false. So there is no expression in the world that is both true and false at the same time. And this is something that you have learned a Boolean expression in discrete structures as well. So a Boolean expression can either be true or false at a time. And whatever it is, based on the value of the expression, we'll choose our path. And that is what selection is all about. Then if I talk about repetition, we notice that, there is again an expression that is evaluated. If it is true, we'll execute a statement and then go back. Then again, to go back to evaluating the expression. And then again, if it is true, we'll continue to execute the statement and continue to go back to evaluating the expression. So this is kind of working in a loop, in a circle. And since this is working in a loop, this is called looping over a particular piece of code, or we also call it repetition. And this keeps on happening until the expression is false. Once the expression is false, we can then move on with the code, whatever we want to do. And this thing is called repetition. So if once you understand the flow of execution, the first one was something that you have already been doing with cout and cin and some of the basic programs that we have used so far. We have been using these sequence of codes. In this chapter, I'll be talking about selection statement. So this side of the code with if else and some other things. And finally, we'll in the next few lectures, we'll be talking about repetition, the for loop, the while loop, the do while loops, etc. So those will be discussed in later lectures. So let's start. when I was introducing the selection statements, I introduced the statements if and if else statements in the objectives, and this is what they are. Um, the basic thing is that if you want to execute selection, as I shown you in the flow chart, you basically need a logical expression, an expression that basically evaluates to either true or false, but not both, right? So you need it. You need an expression that has a fixed truth value assigned to it, or that can be assigned to it. For example, let's say 8 is greater than 3. Is it true? Is it false? It is definitely true. Hence, it has a truth value assigned to it. Or if I say 3 is greater than 8, again has a definite truth value assigned to it. So we need to have a logical expression if you want to execute selection. So if you want to select a path and not don't go over the other path, then for that you need to evaluate a logical expression, and based on that evaluation you can actually come up with what needs to be done. So for evaluating logical expressions, you actually need some kind of operators, because let's say you have a number on the left and a number on the right, and it only you need some operators to assign a truth value to it. For example, is 3 equal to 3? If 3 is equal to 3, then to check it, you basically will be using the double equal to operator. The double equal to operator is basically what checks equality of two particular of the left hand side with the right hand side. It could be a character, it could be a integer, it could be a string, etc. And if they are both equal, this is going to return true. Otherwise, this will return false. So this again has a definite truth value assigned to it. It cannot be both at the same time. So this is a relational operator that we can use to determine the relationship between the left hand side and the right hand side. And this can be used in a logical expression. Similarly, not equal to is the exact opposite of equal to. It basically says that the value is not equal. It can be less or more, but definitely not equal. In this case, this is strictly less than. So basically the left hand side has to be less than the right hand side. And again, this can also be used with strings as well, because strings or characters, etc., because a certain numeric value can be assigned to them. And hence it also evaluates it. The next one is less than or equal to. So the value on the left hand side can at best be equal, or otherwise less than the value on the right hand side, but definitely not greater than the value on the right hand side. In this case, this operator returns the true value. This one is greater than, and this is strictly greater than. So left hand side value has to be strictly greater than the right hand side value, and in that case it's going to return true. Similarly, this one is greater than equal to. So on the value on the left hand side is greater than or equal to the value on the right hand side, but definitely not less than the value on the right hand side. And this will return false only when the value is on the left hand side is less than the value on the right hand side. Otherwise, it will continue to return true. So these are some of the relation operators that we use in C++, and they are used very commonly, as you'll see in the examples as well. And whatever program you're going to make, you'll probably be using one of these relation operators. So let's talk about relational operators and simple data types. So some of the conditional statements are only executed if a certain condition is met. So if that condition or those conditions are not met, then the conditional statements will not be executed. And when we talk about conditional statements, of course, we have to talk about condition. What is a condition? Condition is always represented in C++ by a logical or a Boolean expression that always evaluates to either a true or a false value. So it always evaluates to logical Boolean value. We already have seen the bool data structure, right? So now we're going to talk about a logical Boolean expression. And in a logical Boolean expression, it always uses relation operators. It allows you to compare two particular sides, left hand side and the right hand side. And those two, the left hand side and the right hand side, are basically the two operands. And because it requires two operands, it is basically a binary operator. All relational operators are binary operators. And once you evaluate them, they'll always evaluate to either true or false, but not both. For simple data types, relational operators can be used with all of the three possible simple data types. That is, basically, it can be used with integers, with floats, with double, with characters as well. So, for example, 8 is less than 15, evaluates to true. 6 is not equal to 6, evaluates to false. 2.5 is greater than 5.8, evaluates to false. 5.9 is less than equal to 7.5, it also evaluates to true. So when you compare characters, the expression of character value with relational operators is that the result will depend on machine's collating sequence. And the thing here is that comparing character value is kind of a not so tricky actually mechanism, because we know that each character has a corresponding ASCII character set involved. And in ASCII, we have got an integer assigned to each character. So if you compare two character values with relational operators, it will just convert them into their corresponding ASCII value and then compare the ASCII values. So how a machine collates it, the result will depend on that actually. But most of the time, of course, the ASCII character set is kind of very clear, and there are little chances that there's going to be an error in comparing two characters, except if it is a very special character. In that case, you might want the Unicode character or something, and that is the Unicode integer value conversion is something that may not be the same across machines, but the ASCII character set is definitely the same. So the commonly used alphabets like A, B, C, or maybe some other basic symbols like comma and dot and dash, etc., will all have the same ASCII character set value, and hence the comparison will be uniform across all machines for these ones. But maybe for something special, some really Greek alphabet or something else, it might be then depending on the machine's collating sequence, and might be different for different machines. But since generally the code is run on the same machine, hence the value will always be the same in the machine, and it will hold the greater than or less than a relationship across machines. Hence, still it might be, if it's not a parallel program or a program that is a distributed program running across multiple systems, you will possibly have the same result on the machines for even those characters that are not so common. But for now, let us assume that the ASCII character set is good enough for us. And in that case, we are sure to get the same result across all machines. So when we talk about logical or Boolean expression, for example, let's say that 4 is less than 6 and R is greater than T. These are some things that have a definite truth value assigned to them. So that's why we call them a Boolean expression. And these are logical expressions because they give a certain truth value. So they're logical, like they're either true or false, but not both. So hence they are also called logical expressions based on some logic. So for example, 4 is less than 6 is true. R is greater than T is also not true. So hence in this case, this is going to be false because R is smaller than T. But 4 is less than 6 is true. So this is going to return true. So it basically returns, if you think of what it returns, it actually returns a integer value of 1, which corresponds to true in the Boolean expression, and it returns 0 if the integer value returned is if the logical expression is false, basically. So in this case, it's very clear that you only have got two possible values. You either return 1 or 0 actually, and 0 returns something that is false, and any other integer value will be basically be treated as a true value. And we can try that later on, maybe by putting in a number for evaluating the expression. And that if you put a number, then it's always true. But if it's 0, then it's basically false. And we'll see that as well. So the logical or Boolean expressions actually return a number 0 or number 1. And because they return a certain number, hence the number that is returned will be what is important for us and not the actual expression itself. So every time you use a logical expression, it will always be evaluated, and the return value, if it's 1 or a number, it's basically treated as true. If it is 0, then it's treated as false. and it basically evaluates the expression all the time. So that's what is happening in the backend. And based on the evaluation, it will then choose which piece of code to run selectively and which piece to not to run, basically. So this is all about the logical Boolean expressions. Then we have got one-way selection. So in one-way selection, the idea is that you either run it or you don't run it, right? So this is what we call a one-way selection. So this piece of code will only run if a particular expression is true. If it's not true, then the statement will simply be bypassed, and the program will not actually run it and directly go to the next statement and skip it altogether. In this case, the expression is what we call a decision maker. So the expression, and in this way, and in all selection statements, actually, your expression is what is your decision maker. So this is the point where you make the decision whether you want to run the statement or you want to skip it. So if the expression is true, then we run it. If the expression is false, then the statement will not be executed and skipped altogether. And the program will directly go to the next statement. After evaluating this expression, it will decide if it wants to run it or not and move on to the next statement if it does not want to run it. If it wants to run it, it will execute this statement and then go on to the next statement, whatever is after it. So even in this case, this is basically a one-way selection, and we only either run it or we don't run the statement. And the way to draw it in terms of a flow chart diagram or flow diagram would be that you evaluate the expression. If it is true, you execute the statement and move on to the next statements, group of statements, whatever they are, or at the end of the program. If it is false, you directly move on to the end of the program or to the next statements. So in one-way selection, you saw that we actually skipped the command. We could skip it or we could run it. At times, what we require is you need to evaluate a statement or an expression. If it is true, you actually run a statement. If it is false, you run a different statement. So the idea is that you have a two-way selection. You either choose path one or you choose path two, but not both. And after executing both the paths, you come back to the same place. So this is like there's a turn there. You can take one of the two paths, and ultimately whatever you execute after executing those paths will come back to the same joint road. So in other words, it's like a diamond. So either you take the right turn or the left turn. If you take the right turn, you'll basically execute a certain set of statements, and then you come back to the main program again. If you take the left turn, you execute a different set of statements, and then you ultimately also come back to the joint main road. And this is something that we call a two-way selections statements. In two-way selection, basically, if the expression that is evaluated here, if it is true, then statement one is executed. Otherwise, if the expression is false, then statement two will be executed. However, both statement one and statement two will never be executed together. It will only be that either statement one is executed or statement two is executed, because the expression can only be true or false. If it is true, we execute this part. If it is false, we execute this part. That's it. Where statement one and statement two are basically any C++ statements that we can use, and we'll see that they can even be a group of statements in a couple of minutes. Okay. If we go to the flowchart diagram, we notice that you have got, you're running the program, you actually evaluate an expression. If it is true, we go to this side, we execute statement one, and then come back to the main road, which is the next point in the execution of the program. If the expression is false, we actually go to this side, execute statement two, and come back to the main program again. So in this case, since the expression can either be true or false, so one of these will be executed and the other will basically simply be skipped. So that's why it is called a two-way selection statements. Okay, so then we need to talk about the int data type and the logical or Boolean expressions, how they work. So if you talked about earlier versions of C++, they did not provide built-in data types that had Boolean values. So you had to kind of come up with your own Boolean values. All the logical expressions evaluate to either 1 or 0. So each of the logical expression was actually evaluated to either 1 or 0 directly. And hence the logical expression value in the earlier systems was always stored in a variable of the data type int. So you could not use the bool data type that you can now use, and instead you had to use the int data type, and if the int was 0, it was false, and true otherwise for any number of integers, positive integers. So we could use, and that thing has since continued to exist with the later versions of C++. They still allow us to use the int data type to store or manipulate logical Boolean expressions. And hence we can, at the moment, we can use the int data type as well as the Boolean data type to manipulate logical expressions and evaluate them and store them and work with them. So that thing has still held on, and this is something that is traditional. You can actually use a Boolean data type itself, or if you wish, you can actually use the int data type within the to evaluate the expression, or to within the condition, so that you can evaluate if the Boolean expression is true or false. In the later systems, we actually developed what we call the Boolean data type, and the data type bool actually has logical values or Boolean values of true and false, as we've already seen. And by true or false, it basically only has exactly 2 values, and hence it is generally stored in a bit alone. So the word bool, true and false, are all reserved words that you cannot use for naming identifiers or anywhere else in your code whatsoever, other than their specific use. The identifier true has a value 1 in integers or in Boolean value, and the identifier false has a value 0. Actually, if you talk about integers, anything that is 0 is false, and anything that is not 0 is considered true by the system. And we'll see that what are the repercussions of having this kind of understanding. So the logical or Boolean operators enable us to combine logical expressions, and these logical operators are something that you've already seen in discrete structures in a lot more detail, but I'll kind of again go through them. So the operators in C++ that are used are basically the symbol exclamation mark for not. So not basically reverses the truth value. Whatever the truth value is, it will be reversed. Then you have got the ampersand or and sign, which is used for this and logical operator. And this basically says that if the left hand side and the right hand side condition both are true, only then will this operator return a true value. So this is a binary operator that has a left hand side and a right hand side, while the not is a unary operator. It only has got a condition on the right hand side which it will reverse the truth value of. So whatever is the truth value of the right hand side will be reversed by using not before it. Similarly, if you use and, you will basically be saying that left hand side and right hand side both need to be evaluated to true, otherwise, so that this operator returns true value. Otherwise, if either left or right or both are false, then the AND operator returns a false value. The third one here is basically the OR two standing pipes, which is basically the symbol for OR logical operator. And since this is a symbol for OR logical operator, we'll basically be talking about how the condition on the left and the condition on the right, one of them needs to be true, or both of them need to be true. So if both of them are false, only then the left hand side and right hand side both are false, only then will the OR operator return false. Otherwise, if one or both are true, then the OR operator returns a true value. So if we talk now about the not operator, we see that let's say if you want, if the expression evaluates to true, that is anything that is non-zero, the not expression will always return false, that is a 0 value. However, if the original expression returns a false value, that is a 0 value, then the not expression will always will convert it into true, that is 1 in the integer value. So for example, let's say that A is greater than B. This is basically not true. A is always less than B. And since this A is greater than B is false, hence if you do a not of this particular operator, the value that will be returned will be true. So if we check, for example, 6 is less than equal to 7, which is not true, which is false. If you take a not operator on top of it, and like I said, this is a unary operator, so you only see one condition on the right hand side. Since this is basically actually true, 6 is less than equal to 7, this is true. Hence, the not operator is going to convert it into the opposite, which is false, and hence not 6 is less than equal to 7 is going to be false. Then if we talk about the AND operator, the AND operator is basically operating on left hand side and right hand side in a similar way to discrete structures course. So here what you're seeing is true is basically if the expression 1 is returning true and expression 2 is also returning true, then AND will return true. If the expression 1 is true but the expression 2 is false, then the AND will also be false. If the expression 1 is false and the expression 2 is true, then expression 1 and expression 2 will be false. Similarly, if both expressions are false, then in that case, again, the AND operator will return false value. So if both of them have to be true to return true, otherwise the result is false for AND operator. And then here there are some examples. This one evaluates to true. 14 is greater than 5. Yes. And A is less than B. So since A is also less than B, so this is also true. True and true, as is shown here, returns true. In this case, you basically have 24 is greater than equal to 35. No. And A is less than B. So this is also not true. So since A is less than B, this is true, but this is false. Hence, one of the condition false, the overall return is false. So I'll try to stop here for a minute, and you can actually see the screen here, and we'll continue on with this in a minute. So if you talk about other logical operators and logical expressions, especially the OR operator, in that case, we notice that 14 is greater than equal to 5 or A is greater than B. In this case, this evaluates to true because 14 actually is greater than 5. Although this one is not true, still because one of them is true, the OR operator evaluates to true. Hence, this expression evaluates to true. Then we look at this part. In this part, 24 is greater than 35. This is false. A is greater than B. This is also false. Since both are false, the overall value returned by the OR operator between these expressions is also going to be false. Then we can see that A is less than equal to A. This one is basically A is less than A. Yes, this is true, because if you go to the ASCII value of A, this is, I think, 65. And the ASCII value of small a is close to 96 or something. So this is true. And since this is true, although the 7 not equal to 7 is not true, so a true or not true returns a true value. And over here, hence, this expression also returns the true value. Then if we talk about relational and logical operators, they are always evaluated from left to right. The associativity rule is obeyed, and hence what we need to know is that it will always be the first expression that will be evaluated first, followed by evaluating the second expression. And if you want to evaluate a particular expression first, then you need to use parentheses as much as possible. So if you just write out some relational and logical operators, they'll always be executed from left to right. There is no precedence between a relational and logical operator. However, you can use parentheses to override if you want to evaluate a particular part of code first or a particular expression first before going on to the next one. You can use parentheses. So if we talk about the operators, how they work, well, the unary operators are usually the highest precedence. If you don't use brackets, then this is the way things are going to run. The unary operators will be the first to be executed, followed by the multiplication, divide, and mod signs. Then basically plus and minus have got the third precedence. By precedence, we basically mean which operator actually will first be executed. So if we don't put brackets, this is the order in which they'll be executed. by default in an expression. And we already know from BODMAS actually that, this has more precedence over plus and minus. Then we basically have got less than, equal to, greater than, equal to, or greater than signs in the fourth level. You have got equal to, not equal to in the fifth level. You have got and in the sixth level. You have got or in the at the last seventh level. And finally, anything that is going to be assigning values to the left hand side, which is assignment operator, will be the last to be executed. So with that precedence in your mind, you must always write code and understand code. Although it is always recommended that you use brackets to clarify what you want to do. Otherwise, it's sometimes you need to remember these rules exactly. For example, and I can understand it's very hard to remember that equal to has more precedence over, let's say, plus and minus. So it has less precedence over plus and minus. So plus and minus are the first to be executed, and equal to will be executed at a later stage. So this has less precedence. This is sometimes hard to remember, and because this is hard to remember, I would not really recommend you to use these without brackets as much as possible in your programs. So for example, here's an example. For example, introduce a Boolean found, which is true. Int age is equal to 20. Double R's is equal to 45.3. Double overtime is equal to 15.0. Int count is equal to 20, and character ch is equal to b. Then not found, which is the inverse of the value found. Here we notice that since found is true, inverse of found will be false. R's is greater than 40. The value of R's is actually 45.3, which is true. So since R's is actually 45.3 is greater than 40, so this will evaluate to true. Let's go for not age. For not age, basically the age is an int and it has value 20. Not age is going to reverse the value of whatever truth value stored in age. And as I told you, anything that is non-zero is treated as a positive value. Hence, the inverse of a positive value, a true value, will be false. So since age is true, hence, or evaluates to true in a logical expression, hence not of age would be false. Not found and age is greater than equal to 18. Not found is basically, we already know, is false. So since this is false and age also, age is actually greater than equal to 18. Yeah, so age is actually greater than 18. 20 is greater than 18. Hence this part is true, but since this is false, hence overall the end operator is going to be false. And this expression is going to return a false value. So we talk about not found and age greater than equal to 18. Since found is basically true. Yeah, if you look, found is true. And age is greater than equal to 18 is also true. So this expression, this part of the expression returns a true value. Since this is true, hence, and we take a negative sign, a negative negation of it, not of it, hence this becomes false. The overall result evaluates to false. So here again, we can evaluate them one by one and see what happens. Similarly, you've got another expression which says that the R's plus overtime is less than equal to 75. And this is true because R's plus overtime is 45.3 plus 15. So again, in this case, the plus will first be evaluated, followed by comparing it with less than equal to sign. So if R's plus overtime is, the value comes out to be 60.3. And since this is 60.3 is less than equal to 75, hence this evaluates to a true value. Similarly, we can talk about count is greater than equal to 0 and count is less than equal to 100. So count here is, since count here is 20 and 20 is greater than equal to 0, this is true. And count 20 is less than equal to 100 is also true. Hence this one will evaluate to a true value. A is less than equal to ch and ch is less than equal to z. The character is equal to z. So is A, since the value of ch here is b and A is less than equal to b, this is true. But and if we look at the second part, b is actually less than equal to z. So this is also true. Hence the overall expression will evaluate to true. So you can look at this for a minute and I'll be back with that. But you need to analyze what has happened in these particular three expressions. Because of the order of precedence, one particular side was evaluated first, followed by comparison here. In this case, this had a higher precedence. So this was evaluated first, followed by evaluation of over here. And then finally the AND operator took place. Use of brackets is very important here, but again, even without brackets, this will evaluate to the same thing. You don't really need to use brackets, but with using brackets, you're making clear that this part has to be evaluated first, followed by that part. So for reader, this becomes much more easy. Analyze these ones for a minute, and I'll be back with more examples in the next slides. Okay, so I hope you kind of understand these different expression and stuff. So let's move on. What are the different relational operators and how they are applied to strings? Well, actually, relational operators can also be applied to strings. And with strings, there are, of course, slightly different from what characters are. So but at the same time, since string consists of different characters, the ideas that can be applied to characters can also be applied to strings, but in a slightly more advanced way. So when strings are compared, they are basically compared by character, starting with the first character. So if you want to compare string A with string B, the first character of string A will be compared with first character of string B. If it is larger than, if one is larger, the result will be output right there. However, if both are equal, then the next character in both lines are going to be considered. Comparison between the two strings continues if until either a mismatch is found or all characters are found equal. So if everything is exactly equal and we reach the end of both strings, the comparison will stop and the result will be that both are equal. Otherwise, one of them, whenever a mismatch is found, will be treated as a larger string than the other one. If two strings of different lengths are compared, if both strings have different lengths and the comparison is equal to the last character of the shorter string, then the shorter string will always be less than the larger string. So if, of course, that's the next scenario in strings, that whatever you're comparing had different lengths, but that the shorter one was exactly equal to the larger one until the point of last comparison, then the one that is larger will be given the higher value, and the shorter string will get the lesser value. It will be less than the larger string. So for example, you have the following declarations: hello for string 1, hi for string 2, air for string 3, bill for string 4, and big for string 4 again. Actually, I think this should be string 5. Maybe I'll see the examples. Yeah, this is string 5. So there's a mistake here. This is basically string 5 is equal to big. And if this is true, then let's go on and evaluate some of the strings. So string 1 is less than string 2. Yes, it is true, because hello, H matches with H, E matches with I, E is less than I, so hello is less than hi. Let's see if string 1 is greater than hen. So hello matches with hen, H, H, E, E, L and N. So since L, M, N, L is actually less than N, so this one is basically hen is actually greater than hello. Hence, this will evaluate to false. String 3 is air, compared that with N. So A compared with A equal I compared with N. I is less than N. Hence, this will evaluate to a true value. So let's talk about if string 1 is equal to hello. This will evaluate to a false value, because string 1 contained the string hello. Capital H is actually not equal to small h. And since capital H is not equal to small h, hence the string 1 is not equal to hello, and this is going to be, this statement is false. Think about string 3, and is it less than equal to string 4? String 3 was air with capital A, and string 4 was bill with capital B. A is less than B. Yes, this is true. Hence, the evaluation of air with bill will also be true. So this statement is true since A is less than B. String 2 is greater than string 4. String 2 is high. String 4 is bill. H is greater than B. Yes, this is true. Hence, this evaluation high will be greater than bill is also going to be true. Let's take the next expression, which is basically string 4 is greater than equal to Billy, and string 4 is Bill. So in this case, BILL matches with BILL. However, the shorter string actually ends on the same note, on the equal note with the larger string. But in that case, the larger string is always given the higher value. So this statement is false, and the overall result is going to be false. Then we compare string 5 with less than equal to bigger. String 5 is big, so big matches with big, and this is, since the shorter one matches exactly till the point, so the larger string gets the larger value. Hence, the less than equal to sign for string 5 is true, and the overall expression evaluates to true. Notice these ones are where the match is exactly take place, and but the shorter string has a particular less than greater than equal to or less than equal to symbol comparison with the larger string. Another important thing is the compound statements, that is block of statements that are used for evaluation. Some of the compound statements are basically, or the blocks of statements are statement 1, statement 2 until statement n. So you're basically going to compare different statements together to you're basically going to execute a group of statements that or a block of statements in a single group, and these are what we call a compound statement. In a compound statement, actually, so there's one condition that evaluates it before. If you want to run it, you can run multiple statements in a single group, or avoid these multiple statements and move on to the next one. To do that, all you have to do is put up these special parentheses around it, so that this one is now considered a single group. A compound statement works or functions basically like a single statement, because all of these will either be executed or not executed, or whatever is done will be done commonly for all of them. So with that in mind, these are the block of statements or compound statements. You only need to put in braces before them to make them a group. For example, if age is greater than 18, then you want to run both of these, eligible to vote and no longer a minor. Otherwise, you want to output not eligible to vote and still a minor. And so either both of these will be executed, or both of these will be executed, but not both the groups. So this is a compound statement. This is a compound statement. If you want to run a single statement, you could have written it without these braces. If you want to run multiple statements, you'll always need to use the compound statements and the compound block nomenclature as shown here. Similarly, we could actually go on to the next level, which is the nested selection. By nested, we mean that one control statement is located within another. It can be repetition, it can be basically the selection or anything else. But in case of nesting, we actually put one control statement within another control statement. So for example, for if else, what we need to know is that if you are doing a nesting operation, the else will always be associated with the most recent if, so that there is no confusion between one-way selection and two-way selection. And if you have a dangling else, that can never be done. That is saying that there's an else without an if. So each else will be matched to the most recent if, and if there exists an else that is not matched to any if, that will be a dangling statement, and that is going to result in a logical error, in a syntax error for the program, and the program will point out that this else does not match with any if. So for example, assume that the score is a variable of type int, and based on the value of score, the following code computes the grade. If the score is greater than equal to 90, see out the grade is A. Otherwise, you output score is greater than equal to 80. If the score is greater than equal to 80, you output grade is B, grade is C, grade is D, grade is F. Otherwise, if it is less than 60, you basically output the grade is F. So similarly, if month is equal to 1, then you see out January. Otherwise, if month is equal to 2, you see out February, and so on for the until month 6. You are comparing them. However, notice the difference between this piece of code and this piece of code. In this piece of code, you compare one and you do not perform any other comparison. If this is true, we are done here. We're not going to compare this else, this else, this else, this else, or this else. And in this case, we stop and output January and just move on. If this is false, only then will we move on to the second line, compare for the month 2. And if this is true, then we just output February and move on to the next piece of code directly instead of going through all these else's. But if we talk about this piece of code, here we are actually comparing. If month is equal to 1, we see out January. This if is separate block from this if. So this is checked, 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 regardless of the truth value of any of the previous checks. So even if this is true, this check will still be made. And even if this is true, this check will still be made. Although in the case of month, we usually have a fixed value. That is, it can either be one of these, hence only one of them will be executed. But you need to know that if you put it like this, and let's say if it was a number that, let's say if this was less than equal to symbol, then in that case, all of these, if the month was, let's say 7, then all of them would be displayed. And in that case, all of these checks will be made in any case. Even if this is true or false, the next check will be made. And the next check will be made regardless of value of truth value of here or here. So these are all if. You need to understand that, when it is if else if, and when it is if, it's a totally different piece of code with a different function and different outputs. So here is a thing that we call short circuit evaluation. That is actually, instead of evaluating the whole expression, sometimes once the expression of the evaluation of a logical expression is known, we'll stop as soon as the value is already evaluated. For example, in case of OR, if the first value is true, do we need to evaluate the second one? We don't, because regardless of if it is true or false, the OR operator ensures that this one returns a true value. Because if the first one is true, the second one need not be evaluated. In the same way, for AND, if the first one is false, we don't need to evaluate the second one. Since this is false, we know the AND will return a false value. Hence, if the first one is true for OR, we return a true value. If the first one is false for the second one, for AND operator, we return a false value. This is what we call short circuit evaluation. Instead of evaluating the whole circuit, we just evaluate the part that is relevant to us. And the part, if of course, if this is false in OR, then we will need to go on and evaluate the second part. But if it is true in an OR operator, then we can stop OR execution here and return a true value instead of evaluating x equal to 5. Similarly, if this one is true, if this one is false for an AND operator, in this case, the result already is known here that regardless of the truth value here, this is going to be a false. Hence, we're going to use the short circuit evaluation and return a false value right over here without evaluating the next portion. Then if we talk about comparison of floating points, well, here's the funny thing. The floating point comparison usually does not behave exactly as we expect. So for example, when we try to evaluate that 3 divided by 7 plus 2 divided by 7 plus 2 divided by 7, which if you think of it in terms of decimal, in terms of what you call fractions. So 3 plus 2 plus 2, if the denominator is same, you can add them up. It should be 7 divided by 7, which is equal to 1. Should ideally return true. But when you actually evaluate it or put it on your C++ IDE, it's going to evaluate to false. Why is that happening? Well, because when you notice the value that is stored by 3 divided by 7 plus 2 divided by 7 plus 2 divided by 7, this evaluates to something like 0.99999 something. And what's happening here? And the reason is that each of these doubles or floating points will always be stored with some amount of error in precision error in the last few values. And because there is a precision error in the last few values, the overall is always within a certain error range. And because there's a certain error that is very, very small, the result is not exactly equal to 1. So 1 is not exactly equal to 0.9999999. And hence this one is going to be evaluated to a false value. The way we can actually resolve this particular issue would be to use a tolerance value. What is a tolerance value? Well, a tolerance value is basically something where we say that if the absolute error, if the absolute difference between this side and this side, x and y, if the absolute difference between 1 minus 3.7 minus 2.7, 2 divided by 7 minus 2 divided by 7 is exactly within a certain range of 0.000001, then this should still be true. So for example, if f_abs, if the absolute value of x minus y, and f_abs is basically a function that is given in the maths library that we discussed before, CMaths library, and you need to include the CMaths identifier header in the preprocessor directive, then you can use this particular function, and then you can use this tolerance value to get around this particular problem. So comparing floating points numbers is a totally different game than comparing integer type numbers and character type number and string type numbers. So you need to be very careful, and a precaution is especially mentioned here for you to take care when you're comparing floating point numbers. So here's a program for you to understand. In this case, we enter an integer number and L. If the number is between 0 and 10, we see out num is within 0 and 10, and otherwise num is within 0 and 10. However, you need to understand what's going on here. The number actually, if you enter a number between 0 and 10, actually, let's say you enter a number that is 1, 2, 3 or something, this one is going to return true, and you'll see out num is within 0 and 10. Try entering a number that is, let's say, 20. And this is what you're going to observe. If you enter 20 here, this is still going to output cout 20 is within 0 and 10. Why is that happening? Although 20 is clearly not between 0 and 10, if you entered a number between 0 and 10, yeah, it makes sense that you're outputting this. So the reason is that actually this output is not from the compiler or from the program itself. This is something that you wrote in the program. And if this condition was actually true, it will always output this. So I can put it if 1, if true, then cout this, else cout this. You'll always get the output num is within 0 and 10. And if you put this condition, this means that basically this condition is evaluating to true. So 0 is less than equal to 20 is less than equal to 10 is true. That is what is evaluated by the program. The reason for that is because of the associativity rules. Look, both of them have the same precedence. So first, this one will be executed. This one will be checked. 0 is less than equal to 20. True. Since this is true, this will then be replaced by 1. And once this is replaced by 1, 1 is less than equal to 10. This is true. So the overall expression will return a true value. So the num will always be within 0 and 10, regardless of the actual value of the number. Otherwise, the number that will not be within 0 and 10 will be returned differently. Okay, so the same way, if you enter number 5, this like I said, it will be evaluated to 1. If you enter number 20, it will still be evaluated to 1. And this is the main details here that I just talked about in the previous slide. So, some of the things is that you must always use some concepts and techniques correctly. Always make use of parentheses as much as possible. Otherwise, if you have got some misunderstood concept or some partially understood concept and technique, you'll always make mistakes, and the solution will either be incorrect or it will be deficient. So, of course, if you do not understand a concept or a technique completely, do not use it. That's the first thing. For example, for me, it's very hard to remember, or at times it becomes difficult for me to remember which portion of the expression will be evaluated first and which will be evaluated second based on the precedence. Hence, I usually try to use parentheses as much as possible. If you do not understand, if you do not remember the, for example, precedence, etc. by heart, you should never, leave things dangling. Always use parentheses to make sure that something is of more precedence, of a higher precedence than the other part. And in that case, you'll avoid a lot of mistakes, and that's going to help you save an enormous amount of debugging time as well. Otherwise, sometimes if you don't understand a concept and you actually try to write it out by mistake or something, you're going to make mistakes, and that one will also be very hard for you to debug as well. So that's the take home message here. So in the last lecture we talked about the input failure, and here's the thing. If the input stream enters a failed state, or like I said before, all the subsequent input statements associated with that particular stream will always be ignored. The program will continue to execute, but it may produce erroneous results. That was what we talked about, the input failure, in the previous lecture. However, we can always use the if statement to check the status of input stream. So if the stream enters the fail state, we can actually include instructions that can stop program execution at this point, or we can actually ask clear the input stream again and get to the next level if we desire to do so, and get maybe input again or something. So that's it, I think, about the input failure here. Then we should talk about something about the equality operator and the assignment operator, and that is something that is very confusing a lot of times, even for me, even now. But with more and more practice, I think the picture would emerge clearly to you. What happens if you use an assignment operator instead of equality operator in an expression? So C++ actually allows us to use any expression that can be evaluated to either true or false as an expression in the if statement. So for example, if x is equal to 5, then C out the value is 5 and we'll end L. The problem is that with the single equal to, and this is a mistake that we make because both the operators double equal to and single equal to resemble a silent killer. They are very much similar. We are going to make a lot of mistakes here. And this one happens because single equal to and double equal to, if the font is not large enough, would be very difficult to identify. And x equal to 5 means assigning a value of 5 to x. This will happen, and x will be assigned a value of 5. Since this is true, the expression will evaluate to true regardless of if the value of x is 5 or not. And the program will let you run this. So this is not a syntax error, it is a logical error. And with the logical error, it lets you execute it, but the execution does not produce the results that you want to do. So you must always be careful to use double equal to. You must make sure that wherever you're comparing two variables, it must be done through an equality operator and not through an assignment operator. Then we should talk about the conditional operator, which is slightly different. It is a shorthand way of writing conditional operators. So what we do is that this is a ternary operator. That means that it takes 3 different arguments. The arguments are, the syntax is mentioned here. You need to give an expression, put a question mark sign, then you need to give a second expression, and then then there's a colon, and then there's a third expression at the end of it. So here's the thing: if expression 1 is true, if this expression is true, then the result of the conditional expression, which is expression 1, is the result is going to be expression 2 itself. If the expression 1 is false, then actually expression 3 is going to be the result. For example, max is equal to, so you want to assign some value to max. If a is greater than or equal to b, if a is actually larger than or equal to b, this is the first expression, followed by the question mark, followed by the expression 2, followed by colon, followed by expression 3. So if I have to evaluate this whole statement, it will basically be excuse me, if a is greater than or equal to b, then if this is true, then the result is a, and a will be stored in max. If this is false, the result is b, and b will be stored in max. And this is exactly what you want to do. So this expression is evaluated, and the result is then put into max. This is all about conditional operator. Usually you don't use it a lot of times in the code, but I think it would be a good idea to use it sometime in your code, so that you're aware of how this works. A lot of good programmers actually do this to save a lot of time, and this is why I'm kind of really focusing, or really want you to use it sometimes in your code, so that you are aware of how this is used and how this is read as well. This is not a mistake, there's no error, there's nothing wrong here. This one is what we call a ternary operator, and this one is what how we use a conditional operator to assign values to different variables in a single line instead of line writing. This is same as writing, if this is true, then max is equal to a, else max is equal to b, and this is shorthand way of writing it. Okay, then we should talk about the program style and form and revisit that. Another thing that is very important is indentation. And indentation basically means how many spaces you give between different points, how you put in different groups of commands in your new program, and how you differentiate it from the previous commands or the next commands. So a properly indented program will help you spot and fix errors quickly. Debugging becomes much easier. It will show you the natural grouping of statements. For the reader, this becomes much easier to read your program and understand it. And even for you, it becomes much easier to go through your own program really quickly. So what we typically do is that we can insert a blank line between statements that are nicely separate. So for example, declaration versus conditions, etc. So you can put a blank line, an empty line between them to differentiate between both groups. If you want to put braces, there are two common ways of putting braces, and both of them are absolutely fine. I personally use the second one here, but I'm fine with the first one as well. You can put them on a single line by itself. So you can put the braces, the opening braces for compound statements in the line, and in the next line, you can put the closing braces in a standalone line. Or the other way is that you put the left braces is placed right after the expression, and the right brace is on a line by itself. So this one saves a line for you. The left brace is always put up after the end of the expression, while the right one is on the line itself. So this is something about indentation of a compound statement, and this is something that has helped me a lot over time. What is a pseudocode? We talked about a little bit about it in the zero lecture, but I'll go through it again. The word pseudo is basically mean wannabe, right? So a pseudocode is something that is looking like a code, but not really a code. A pseudocode is basically how you write an algorithm in terms of which is closer to C++. It is basically an informal mixture of C++ and your ordinary language. So this is somewhere in between an English algorithm and a full code. So it's an informal mixture, but it helps you to quickly develop the correct structure of the program and avoid making some common errors. So this is more useful than a pure algorithm for programming in C++, if you want to go on that path. We can use a wide range of values in a walkthrough to evaluate the program. So we can use a wide range of values here to evaluate the program. The switch structure is again something that is very much related to the to our selection statements, and this is something that I'm going to focus a lot on. This is something that is very commonly used, again, just like if else, and it also saves us a bit of time in a lot of cases, as we'll see in the examples. So the switch structure is basically an alternate structure to if else or statements. The thing here is that the switch expression, this is the if you want to know the syntax here, the syntax here is that you write switch, this is a keyword, you write an expression, this is the expression that is an integral expression, and this is evaluated first. So this expression can actually return an integer value, or it has to return an integer value. If the value is equal to value 1, then the thing is this statement will be running, followed by a break statement. If the value is equal to value 2, this statement is going to be running, followed by a break statement, and so on until the value n is checked, and the statement n is run, and followed by a break statement. And look, if you notice, these are all statements and not statements. So you can have multiple statements over here. You don't need to put in braces for them. They will be executed step by step until you encounter the break. So on encountering the break, move on to the next level. And if none of them is none of the values is matched, only then will the default statement run. And notice here that this is basically the statements and then there's no break after it. So this is the syntax of it, but I'll talk more about how this is being executed. First of all, the switch expression is evaluated. The expression is evaluated to an integer. If the value is, and then the value of the expression determines which corresponding case is going to be running. So expression here is what we can call your selector here. In the switch statement, your expression is your selector. Which part is going to run is decided by the value of your expression, and hence it is your selector. This is the same selector that our previous beloved leader also talks about. So the expression here is what chooses what is to be running next. This is the what we know is the flowchart diagram of the switch statement. You basically have got, you start from an expression, you can evaluate the case value. If it is true, you execute this group of statements. Then you break and move on to the end of the program. Otherwise, you check for the next case value and so on and on until you finally reach the default. If all the previous values are false, only then the default will be executed. The statements will be executed and you again move on to the next phase of the program. So here is the thing. You can have actually just a single statement following a case label, or you can have multiple statements following a case label. As I said before, braces or brackets are not needed to turn multiple statements into a single compound statement. If you have multiple statements, they'll all be executed regardless of presence of braces or absence of braces. When a case value is matched, all statements after it execute until a break is encountered. So everything that is after a case value, all those statements will be executed until we finally encounter a break statement. The break statement may or may not appear after each statement. We did put in a break after each one, but you may skip it as well. It's not necessary to have a break, but there are repercussions of it. And the repercussions will be talked in the next slides. We'll see what happens. You need to know that switch, case, break, and default are all reserved words and keywords. You cannot use them to name your identifiers. Here's an example. Case A, the grade point is 4. Case B, the grade point is 3. Case C, the grade point is 2. Break again, case 2, and blah, blah, blah. Right? So here we can see that there's no break statement, but here we do have break statement. We can even skip them if we want, but there are repercussions. So, but here's the thing. We have actually used grade, which is a variable of type character here. So this is character. Remember, we cannot put floating points here, but we can put characters here. Character is a type which has got an integer associated with it. And like we said, the integral value is something because the integral value associated with this grade here is basically same as the ASCII value of A, B, C, D, F, or something else. And if the grade is something else, we get the grade is invalid. Okay, so to avoid bugs and to output results correctly, we should consider whether the switch structure must include a break statement after each count statement. So after each cout statement, do you need to put in a break statement or not? If you don't put a break statement, it will actually continue to execute. This is what is already mentioned here. So let's suppose that if your break is not encountered when the first case value is matched, and all the statements have exited, then every other case value that is put before the first break statement is encountered will also be executed. That's the problem here. So if you don't put a break statement in every case, for example, if I miss a break statement here, and if the expression value match 1, then I'll have statements 1, all of them executed, statements 2, all of them executed until the first break was encountered. Because there's no break here, I missed this break. That would actually mean that everything in this case will also be executed. And that is sometimes, or most of the times, 99% of the time, that is not desired. A time that might be desired, for example, small a and small b, you want to run the same statements, you'll just use case value 1, case small a, colon, miss all of these, and then talk about case small, case capital A, colon, and then execute statements 2 and then break. So in that way, if it's either a small a or a small capital A, the statements will be executed. and finally break will occur. So sometimes it's useful, but most of the time this is something that is not desired. So you must remember to put break. The common error here is that you forget to put the break statement. And you must always check that a break statement is always printed inside the switch structure at the right places. So when you're terminating a program can actually be terminated by using an assert function. What is an assert function? Well, an assert function is useful in stopping a program execution whenever certain types of errors occur that we cannot catch during when we are making up the program. So for example, a division by zero error sometimes occurs because of a certain wrong input by the user. And in order to stop that particular kind of input, you can either basically use an assert function or use an if-else statement. So that if statement is kind of shortened by using the assert function. So what does an assert function look like? An assert function simply looks like an assert expression like this. So expression here is any logical expression that can evaluate to true or false. So if the expression evaluates to true, nothing happens. We are done. We can move on to the next statement. However, if the expression evaluates to false, the program will terminate here. It will stop execution here and indicate where in the program that particular kind of error has occurred. Why this happens is because you want, if the expression has become true, then you say that, okay, since the assertion is true, we can continue on. But once the assertion becomes false, we'd actually want to stop the program there and tell the user that this particular expression is going to cause you an error in the next lines. So there's something wrong in the input here. There's something wrong with the expression here. And you need to fix whatever variable needs to be fixed to move beyond this particular point. In that case, the program will basically stop or terminate and indicate. So this is a very good debugging tool. To use assert function, you must always include the C-assert header file, and then you can use assert commands wherever you want. The alternate, of course, is to use if-else if you don't want to use assert and include this header, but that's a lengthy procedure to actually get the same thing done. As well as the assert function actually indicates the line of the program or the place where a particular session has failed. In the if-else, that is the harder part, and you need to write a lot of code actually to get to that point. So like I said, assert is actually useful for enforcing the programming constraints during program development. And after developing and testing a program, we can actually remove or disable the assert statements. How can you disable it? Well, basically you can simply put the preprocessor directive hash define and debug before the directive before the directive hash include C-assert to disable the assert statement during normal execution. So if it is not in a debug mode, then we will not include the C-assert statement. But if it is defined if it is running in a debug mode, only then will we include C-assert. And once we include it, the assert statement will be, if we include this particular statement, then the assert statement will be disabled during normal execution, but will only run once we are debugging the code, right? So to summarize my whole lecture, the control structures will alter your normal control flow. That is, it will not run in sequence, but there will be certain abnormalities that will be observed when you use control structures. Most common control structures are, of course, selection and repetition, and maybe functions as well that we'll discuss later. The relational operators are given here. Then you have got logical expressions which evaluate to either true or false, 1 or 0. And the logical operators are typically available are not, and or, represented by these symbols here in C++. There are two selection structures mainly. One is called the one-way selection and the other is two-way selection. In one-way selection, you either run a program or you don't you run a piece of code or you don't run that piece of code. In two-way selection, you either run first piece of code or you run the second piece of code. The expression in an if or if-else structure is usually a logical expression or a condition that we call. No standalone else statements is allowed in C++. So every else has to have a related if. Otherwise, the program is going to generate a syntax error for you. A sequence of statements enclosed between braces is called a compound statement or a block of statements. They'll be executed together or not executed together, not executed at all. Using an assignment operator in place of the equality operator is a common mistake, and it will create a semantic error, logical error, not a syntax error. So you need to be very careful when you are using assignment operator and when you really want to use an equality operator. So both of these operators really need to be used very carefully and not mixed up with each other. They have different purposes. A switch structure handles multi-way selection. So like I showed, switch and case statements usually have a very good usage. Break statement ends the switch statement. So wherever you break, the switch statement will be ended at that point. And finally, we can basically use an assert statement to terminate a program if certain conditions are not met. So assert statement is actually useful to make sure that certain conditions have been met at that point. It is particularly useful in debugging. And then there's a certain way that even if you have an assert statement, you can actually undefine it during normal execution, but keep them defined during the debug mode. And with that, the chapter comes to an end, but now I'll go to some of the examples of this chapter.